Hey guys, it's Jermaine LeGrand again, and we're going to be doing another discussionary video about tangent planes and equations of tangent planes to surfaces at points. We've previously discussed this in other chapters, but we ended up using like other methods to get there, such as cross products and dot products. But today we're going to be talking about gradient vectors. So here we go. Given z is f of x and y is 8 minus 2x squared minus y squared at the point P with x is 1, y is 1, and z is 2. Find the equation of the tangent plane to surface at point P. So what I'm going to do is, just like last time, I'm going to break down everything into steps, and we're going to write down what we already know. What we already know is the plane equation, which we've already used before in the past, which is a times x minus x naught plus b times y minus y naught plus c times z minus z naught is 0. We're going to be using that to figure this whole thing out. Step 1. Find a, b, and c. What we already have is x naught is 1, y naught is 1, and z naught is 2. We got that from our point right here. Step 2. Change z is f of y, x and y is 8 minus 2x squared minus y squared to implicit form. And why are we doing this into implicit form? Because we're going to be talking about level surfaces and surfaces in 4D. So that's why we're going to change this into w with respect to x, y, and z is 2x squared plus y squared plus c. That's our step 2. Step 3, just like we just said, we're talking about level surfaces. So we need to change this into and give it a k is constant. So we're going to have 2x squared plus y squared plus c is k, with k being constant. Step 4. We're going to find our gradient vector w. Our gradient vector w is going to be 4x, 2y, and 1. How do we get that? All we did was differentiate this whole thing right here. Simple as that. I drew a little picture right here so you could get a little feel of about what we're going to do. But let's just keep going. A little side note that I put right here is that the gradient vector is always normal to the level surfaces of W. So if W was right here, the gradient vector would be normal to it right here. Alright, step 5. We're going to take all the points that we have from points P, and we're going to add them into our gradient vector, which we have here. From that, we're going to get our points A, B, and C, 4, 2, and 1. And as we know, when we have a vector and a point, we can use those to easily find our plane equation.